So now let's continue with tutorial. So we have a company called Kirana Incorporated, and they purchased a gas compression system, a GCS, at a price of 250,000 US dollar, and they want to use it for their Herlang field. And the field has a remaining lifespan of about 5 years. So that means that they are going to use it for 5 years. Now, let's construct the depreciation scheme for this gas compression system, and we are going to do this using the different methods of calculating depreciation. So we will be doing the depreciation scheme based on the single declining balance, the double declining balance, the 25% declining balance, as well as the straight line method. So when we do this, we will be able to see how the different methods behave, and then we can make a comment on these different schemes. Now, when we deal with declining balance or comparing the different kinds of scheme, it's always a good thing that we do it in a table form. Okay, so first of all, we construct a table. And once you construct the appropriate table, then we have to identify what are the formulas that we need to calculate the declining balance formulas and the straight line method. And then once we have done the calculation, then we can analyze the output and give our comment. Okay, so recap on the formula. So these are the two formulas that we will be using. One is the declining balance formula, which has the P here, and the second formula is this straight line method formula. The P here, the value of the P changes depending on the type of acceleration that we intend to use. If it is a single declining balance, then therefore P is equal to 1. For double declining balance, P is equal to 2. For a 25% declining balance, then the ratio P over N now will be 0.25. Okay, so first of all, you prepare a table that looks like this. Okay, so you have the year at the topmost row, and then we have the different types of depreciation at the first column. Now, let us start with the single declining balance first. For single declining balance, so remember, P will be equal to 1. Now, for year 0, we know that the year-end value is 250K, okay, which is the initial cost at year 0. To calculate what is the book value or year-end value at year 1, then we look, this is the formula that we use. We are looking for the year-end value at year 1 equals to the initial cost, which is 250, multiplied by 1 minus P here is 1, divided by N, and N is the life of the field, which is 5 years, and then to the power of the year that we are calculating, which is 1. And doing that should give us a value of 200. Okay, so this means that on the first year, the company has actually recovered $50, okay, because the difference between the initial cost and the book value at the end of year 1 is the difference between these two values. All right, now, so we move on to the second year. On the second year, using the same formula, A at year 2 equals to the initial cost, 250, multiplied by 1 minus 1 over 5 again, to the power of 2 now, because it's year 2 and you should get 160. Now, the depreciation at between year 1 and 2 is $50. So you will realize now that the depreciation changes with time. We continue to do for year 3, where n is equal to 3, and you should get a year-end value of 128, and therefore the depreciation for this year is 160 minus 128 is 32. Continue to do it on year 4, n equals to 4, so therefore the year-end value is 102.4k, with the depreciation amount is 128 minus 102.4 is equals to 25.6. So you can see a trend here. You can already see that the value of the depreciation has decreased. So you can predict also on year 5, doing the same calculations, you give you a year-end value of 81.9 and the depreciation is 20.5. Okay. If we total up all of these depreciation, it will give you a value of 168.1k. So that means that's the amount of value that the company was able to recover from this gas compression system. Now, let's compare with an even faster rate of depreciation, which is the double declining balance. With double declining balance, the P now is equal to 2. Using the same formula, we know that the cost is 250. At year 1, A1 equals to 250 multiplied by 1 minus 2 over 5 to the power of 1 because it's year 1. And you should get 150. Now let's see what is the depreciation for that year. So on the first year, the depreciation or the amount that they recovered is 100. So you can see now this value, 100k dollars depreciation, is much higher as compared to single declining balance. So that means this double declining balance has a faster rate of recovery. Continue on with year number 2. For year 2, if you do the calculation, you get 90 as the year-end value and the depreciation is 60. If you compare again with a single declining balance, 60 is still a bigger depreciation as compared to the single declining balance. Continue with year 3. The year-end value is 54 with the depreciation amount of 36. So you see now, even at year 3, it recovers even faster than single decline balance. Continue on to year 4. The year-end value is 32.4 and the depreciation is 21.6. So here you can see now that it starts to slow down. The depreciation value here is actually lower as compared to single declining balance. Let's look at year 5. A5 is 19.4 and the depreciation is 13, which is also lower than single declining balance. Anyway, let's just total up all of the depreciation and you will get a value of 230.6. So overall, in total, double declining balance still recovers more than single declining balance. Okay. Now, what about you would like to do 25% declining balance? So you do the same thing. Now, instead that P over N, the ratio P over N here becomes 0.25. So doing the calculation, using the same formulas, if you all these values, and if we look at the depreciation amount, you will see that actually if we compare year 1, the amount of depreciation is somewhere in between single declining balance and double declining balance. You can see that also in year 2 and so on. Now remember that we have done a tutorial on single line method, which is the simplest method, and if you still remember, this is the formula that we use for single line method. For single line method, if you still remember, the depreciation amount is the same every year, and the year-end value at the end of the life of the equipment is always 0. If you look at the total amount of depreciation recovered, the total depreciation is 250, which is equal to the initial cost. So that means that all of the cost of that gas compression system has been recovered at the end of the equipment's life. All right, so if we put those values in a chart, okay, then it's even easier for you to do the comparison. Let's say that we compare between the single declining balance and the double declining balance. The yellow one is a double declining balance. You can see that if you look at year 1, double declining balance has a faster recovery rate as compared to single declining balance. Same goes for year 2. But the curve actually slows down for double declining balance a little bit, not very significant. If we compare these two graphs with 25% declining balance, you see that the recovery rate is in between double declining balance and single declining balance. If we were to choose between these three, we would prefer to do double declining balance because you get more of the cost being recovered at the end. You have the lowest book value. Now, if we compare with the straight line method, if you remember the straight line method, it's a linear line. Again, comparing at the first year, double declining balance is far better than single line method because it gives this faster recovery. However, what the declining balance do not have or cannot achieve is to get this full recovery at the end of the equipment life. So no other methods but than single line method can do this. If we look at it in another way, in another chart, let's say we plot all of the depreciations amount every year in the chart, you can see again. And the first year, the yellow one is a double declining balance. Double declining balance will recover the most depreciation, the most amount on the first year. Also on the second year, double declining balance wins. But you can see that around the fourth year, somehow the single line method wins the race. Okay. So when we decide on which method to use, there are many different considerations. There are actually two considerations that we have to take. First of all, we have to justify with respect to the duration of the recovery. How fast or how slow is the recovery of the initial investment? In this case, we know that double declining balance would give a faster recovery. But we have to also look at the amount that you can recover at the end. We want to achieve full recovery of that investment, and in this case, only single line method can do this. So what should we do now? Is there another way that we can have both advantages that we want? Yes, there is such a thing called combining several methods.